Good day there. I was speaking to a colleague yesterday who reminded me of a particular topic that I have not yet done a video on, and well, it's frankly very important, so I'm taking this opportunity to do it right now. Um, we're going to pick up from here. This is a video that I did a couple years back, I guess, on using MQTT with ThingWorx to do an IoT Hub integration. And there's something hiding in here, and I know that there's a lot of people that are using MQTT, and I wanted to dive into a particular behavior that you may or may not have noticed, and I'm going to explain to you what's going on as well as how to avoid it. So picking up kind of where that left off, right, if we come and have a look at what was going on. We had MQTT messages. Maybe I'll start over here. MQTT messages coming from Kepware in the IoT gateway, where we had an agent set up in the IoT gateway that was connected to each of these devices. UK Newbury plant, line 1, line 2, line 3. And here you can see 5-second send interval, narrow format. So I'm going to build up a narrow format the messages over a particular period of time that are configured for this agent. So here there's 3 tags. There's 3 tags for each: ramp, random, and sign. They're all different, but they are simulated values coming from Kepware, and these are coming in at 250 millisecond scan rate. And as I explained in the first video, the intention here is not to say you should do this. It's just to say, look, we're going to get a lot of data, and that's the point here. We want to see some high resolution time series data and see what this looks like when it's coming in chunks, because that's the point here, is that the resolution of the data is in a small resolution that's going to be handled in batch when those MQTT messages arrive in batch. Here the batch sizes are 5 seconds. We're going to have a quick look at those batches, and then we're going to actually increase the batch size and see what happens if we did some store and forward. So here, this is just a chronograph dashboard that I've built that has a look at the data that's coming in, and you can see here past 5 minutes, 5-second interval, and you can see some nice sine waves. Because we do have 250 millisecond intervals, you can see here the specific resolution and frequency, and we can really get into looking at the specific data. So one thing that you'll notice when I go back to 5 minutes here is that the auto refresh on this dashboard is set to 5 seconds. I mentioned that the packet size was 5 seconds as well. So Kepware is just building up all these tags inside the message before it sends them. Let's refresh this. I think it's kind of having a difficulty here. 5 minutes. Yeah, it's struggling. Okay, so let's pause auto refresh. I think the browser trying to render all these points is having a little bit of a difficulty. In any case, we will see that they're coming in chunks. Clearly they're coming in chunks when the browser is refreshing. And what we're going to do, maybe while we give this a little bit of time, is we're going to come over back to Kepware, and we're going to change the chunk size to 15 seconds. So there's going to be a lot more messages within the each message that arrives, and they're going to be much farther apart. But all in all, the data is still the same, right? We're just sending less messages. The only thing is, I hope we don't fill them up at the 15 seconds. I haven't checked that we'll actually be able to fit this many messages, without hitting the max events per publish. That's our ceiling for the IoT gateway here, as far as how many messages we can fit into a single message. Tag updates, we'll call them. So let's see what happens here. This is really struggling. Okay, so dashboards. Okay, there we go. So we're back. So pause this 5 seconds. We'll see if that's taken already. Basically, we should see this updating still the dashboard every 5 seconds, but the messages themselves should only be coming in every 15. So we should have some delay here. And the reason for doing that is that I want us to see that we are building up some delay through time because those batches haven't been processed, and then they're coming in, and you can see they're actually being processed slightly out of sync with one another. And that's really just based on when I clicked OK, right? But they are still filling in. We are getting all of the data coming in here. Perfect. Okay, so kind of a quick reminder how this is working. I've got this parse message service that is taking apart those JSON messages. You can go and have a look at the original video that goes over how to set this up, but basically I'm just looping through the contents of that JSON payload in the MQTT message, and I'm doing an update subscribe properties service call on an info table. So that info table is a combination of the VTQ, value, time, quality, for each of the property updates, and that gets executed at the end of the service. So what I'm going to do is just go in here and shut down my IoT Hub Connector. And I'm going to go have some lunch, and we're going to just let this sit. So this is kind of simulating a store and forward situation. Kepra is not offline. Kepra is still online, communicating with IoT Hub. IoT Hub is building up the message retention within its partitions. The ThingWorx is no longer getting any data. Right? If we come back over to chronograph, we'll see that we haven't gotten any data in some time, and I'm just going to let this run for an hour or so, and we'll come back to it and see what happens. Okay, we're back. It's been just under 1 hour. We should be at the 1 hour mark in a couple of minutes when we're all ready to go. So let's do this. We have 1 hour's worth of messages. I'm just going to, as a reminder how this works, right? We've got an entity that those JSON messages are coming in here. They've got a remote mapping on the source here for the one of those Newberry plants that's going to map the JSON into here. That's going to fire a subscription that is on DataChange event when that property changes. The DataChange event is going to fire this parse message. It's going to pass in this parse message, the event data, to this parse message service that's going to do the parsing. And at the very bottom, you can see it's building up the rows, add rows to the update values with the property name, the quality, and the value, as well as the timestamp, of course. And then at the very end, we're going to do this update in batch, update property values, taking that prepared info table of type property VTQ, I think it's called, named VTQ, data shape. And so what we're going to do is let's use the subsystems for utilization subsystem. And I'm just going to reset the utilization subsystem metrics, services, utilization statistics services. And let's say reset all of the statistics here. And so this will give us some counts on some subscriptions and service executions in the particular period that we are looking at, so that when we come back and look, we should be able to see some property sets, some service executions that should kind of match around that time period. So we're almost at our time, kind of quickly having a look at this. Let's say look at past 1 hour. It's actually now that we should be firing this up. Past 1 hour, past 6 hours. It's a bit much. Well, let's just put it back to 1 hour and we'll watch it kind of fill in. So as this is refreshing, we should be able to see it kind of fill in as the messages are coming in, right? Because we're going to try and get caught up quickly as possible. And those messages are going to be read, and there's some subtleties here that I'm not describing right now, but they're going to be read in batches from the IoT. So they're actually going to come in from the IoT Hub way faster than and in parallel that they were before. So let's start this up. It's going to take a second. While this is starting up, 45, we'll just flip it back over to this screen. I'm going to do a quick calculation to kind of figure out how many messages we ought to have. Okay, we got a whole bunch of stuff there for line 2. Okay, and we filled in the last parts for line 2. Caught up on line 2, but we've got a bunch of holes in there. We can see we've got these data gaps. What's going on for line 1 and line 3? Okay, there's those other 2 guys. Okay. You can see these holes. They're clearly not being filled in, right? We're giving it some time. If I come back to 5 minutes, 5 minutes is better. We see the close precision here, but we still see that there's these holes here. And if we wait, are we going to see things starting to come back to normal over here? It looks as if so. There we go. So it's come back to normal behavior, but we've got all these holes over here. I'm not really looking surprised. I knew this was going to happen. This was what I wanted to show you, actually. And the question is, what's going on here? What happened to the data in here? And this is why we're using the chronograph. Because here we're actually looking at the data that's in the database, right? So we haven't really talked about what's happening in the platform. But in the end, when we look at the data that's landed in the database, we're clearly, we've got these gaps. And you saw that over the 1 hour period, if I go back to 1 hour period, there's a lot of big data gaps, right? And these are not trend issues. These aren't drawing issues. These are, the data is simply not there. So let's have a look at why. What happened to it, where it went. So I guess I'll stop this in the meantime. I don't think we really need that running. So we should have had about 240 messages per line there for the 1 hour period. And let's get some entity statistics. And this is sorted by count. So right away we get the ones we're interested that come to the top because of the frequency, as we just reset it before coming into here. And we see that there's some services. I do have entity level statistics enabled here, so we see for each of the 3 that are coming up here, and we've got these update subscribe property values, right? So that's the service that's being executed at the very end of that parse message service that's telling us, look, I got some messages, I parsed the payload, and then I've sent this off to the batch, and here we have 300, 290, 282. Oh wait, sorry, update subscribe, right. So here we can see the update subscribe values. That's what's being called at the very end, and then we've got the parse message service as well. But we can see, just comparing the parse message and update subscribe values on line 2, not the same, right? We've got 191 here versus 300, which is a little bit strange. And then this is interesting, is here we have the data change. So here we have the line 2 data change values, and we got 191. And 191, so 191 has triggered 191 parse messages. And if we look at the other ones, line 1, we have 130 parse messages, update property values 130. Nowhere near the, what was it, 240 I think we were expecting. And so this is the source of what our issue is, and we're going to have a look at that right now. If we come over to help file and we just go to ThingWorx help centers, I'm going to go back through the release notes a little ways, specifically on ThingWorx version 8.5. I think it was 8.5.7. You know what? We're just going to search for it. Okay, so yeah, this was backported, it seems. But if we look at 8.5.5, there's this notion of addressing an issue to allow historical property value to be stored with the provided timestamp, and the addition of a new import option to overwrite property values, as well as a new event. Okay, so what's going on here is that around this time a couple years ago, this notion of store and forward, of batch processing of properties, and here we're making reference to the import option. There's a number of ways that we can actually import properties. But what was happening was that data change event was being triggered for all of the scenarios, including, like, imagine you have a file that it's got months of data in it, you've got a kepware that's disconnected, you've got an IoT hub that's disconnected, whatever the scenario is that's coming and doing some form of batch update of the property values was triggering that data change event. And that is an undesirable operation, right? Because that's going to mean if you have any subscriptions that are tied to the data change, you're going to be triggering back through a large amount of history, refiring those services. That's essentially, that's the biggest issue here, and this is what has been addressed. The other issue is that we don't want to update the value in the thing model, right? Because the thing model should be the current and the latest representation of the value. It shouldn't be showing us something that happened a day ago. If we had a more recent value and then all of a sudden we got a value from a day ago, we shouldn't update the thing model with that old value, because it's giving us a bad representation of something in history which is actually no longer relevant in the present. So this is what's changed. And the reason, if we come back to our scenario, what's happening is that because of the fact that I have queued up and simulated essentially a large amount of load by disconnecting the IoT Hub connector and building up all of these messages, when I did reconnect it, what's happening is that the platform is leveraging multi-threaded capabilities in order to handle that increased load. And by leveraging multi-threading, it's spreading across the multiple threads all of those property updates. So the property updates for those JSON payload messages go across the threads, and because of this, they get slightly out of order, can be by a millisecond or so. And any change in order means that now, because of this new functionality also in how the incoming data is updating the thing model, this means that only the latest data point in the thing model is going to actually update the value of the thing model. Okay, this makes a lot of sense if we think about the fact that we get something from yesterday. We don't want that to be represented in the thing model. We do want it to go to the database, however, right? We don't want it to show in the thing model. We do want it in the database. And this is where the addition of this new event arrives. But you probably didn't know about this event. I certainly didn't know about this event when I found out about this. You might have seen it in Composer, but here we can see that we've got these data change events that are firing. But if we come back over here to our setup and we have a look at the subscriptions and we have this data change on that JSON value, I can add another subscription here, and we'll call it values historical data changed. Well, and this is fine. We'll call it logged because that's the name of the event, historical data logged. We're going to enable it. The input we're going to take is, you'll see it right underneath data changed, is historical data logged, and this is essentially the pair with data change. So data change is used since 8.5.5. It's used for signifying that there has been a new property set, okay, that has arrived, depending on how the property is configured, that is newer than the last one. So if it's older than the last one, then instead of triggering data change, it's going to trigger historical data logged. Okay, so that's what we're going to tie to here. Property, we want this values one, right, because this is the payload that we're going to be decoding, and I want to trigger on this property and event combination. And basically I just want to like me dot parse message here, payload is event data value, right? We want to take what's coming in the event flow. This is very important too. Let's talk about this for a second. We have to take what's coming in on the event, because if you think about the fact that this is happening in a parallel nature across multiple threads, this same property set for the same entity and the same property could be coming in on multiple threads, right? So we need to keep it relevant so that the message, the JSON message, which is the value of the property set, is coming in here. That's going to take it over to the properties to be parsed. If I were to say that differently and wrong, I would use, like me dot value, whatever that thing was called. I think it was called values, right? Me.values, what this means is parse message, but take it off of the thing model, right? So whatever the current value at the time of execution of parse message would take it off of the thing model, but we don't know when that's going to happen. We don't know what's going to happen across the multiple threads. If we have 50, 100, 150 threads, we don't want to be pulling it off of the property value on the thing model for a couple reasons. One, it's going to be wrong if we're using parallel processing. But two, we also don't even know if those values are going to update the thing model, because remember what I said, we don't update the thing model with an old value. So if something gets slightly out of order, that means one of the messages you're not going to miss because it's going to be dumped to historical data logged. Historical data flow and not live data flow. So here we're keeping the event flow intact by taking the event data from the value. We're going to say OK, and we're going to save this. It's enabled, and we're going to wait for a while and come back in an hour or so, and we're going to do the same thing, and we'll see what the result looks like then. Okay, so about an hour and a half has passed, and same scenario as before. Kipper has been sending data for 3 lines every 15 seconds to IoT Hub. This has been building up for longer than before, an hour and a half as opposed to 1 hour. And now we just have changed things a little bit in the makeup here. Instead of just triggering on the data changed event of that JSON payload, we're also going to trigger a subscription on the historical data logged to parse the message. So essentially just kind of creating a Y path for anything that comes in that's older. We don't really care about the timestamp of that MQTT message, because what's important is inside it, right? We do have the time value on the source tags, and that's really what we want to get at, and that we're going to get at within the service. That's going to pass it to the update subscribe property values. So let's see what happens. Getting ready to start this. I'm not actually going to do it just yet. So 1.5 hours, 90 minutes times 4. So we should have about 360 records, and I forgot to do the utilization statistics reset. So we're going to reset these statistics again. Done, and we want our chronograph up here, so looking at past 1 hour every 5 seconds. Okay, so no data. Let's kick this off. So it is going to come in quite quickly as it did previously, but we ought to see a slight difference. So here we do have some of these kind of gaps, but you can see they're getting filled in, right? Because we're using the timestamp from the source data, so it shouldn't really matter when we process that timestamp. And that's kind of the core to, you know, timestamp at origin is using a timestamp at origin. We don't really care what time the processing happened or what time the messages were sent around. So that's essentially, you know, best practice. And, you know, no matter where I look here, if we kind of zoom in, we see data consistency, and this is exactly what we wanted to see. Let's just go and shut this off again. And we'll have a look at the utilization subsystem metrics, get entity statistics. So what did I say? I said about 360, right? That's interesting. Data change. So here we have 368 data change for line 2. Line 2, we have 109 of these historical data logged, right? So this essentially combining the line 2 data change and the line 2 historical data logged is giving us our total. And I'm assuming that our total is going to be 409. It should be quite similar across the 3 lines because they've been shut off across the board. But basically you can see here by coupling the data change event and the historical data logged event, this is going to ensure that we actually get each of those events, right? So I'm really talking about the events. And I also mentioned this earlier, is don't use the property on thing model, right? Because that's not multi-threaded. That's going to just be current time of execution. Here we're using the value that is coming in all the way up the chain that we're pulling off of the event flow. So I guess just to close, a kind of a final couple thoughts. Definitely put some comments if you'd like in this video. I mean, I do plan on going deeper into this subject. It is quite a deep subject actually. But one other thing just to keep in mind is that here we've been talking about JSON format. And so any message that comes in is going to be considered changing, even though I have the default setting of value, right? So here this is going to be slightly different if we're talking about Boolean values or we're talking about numerical values, as is explained here by putting the mouse over this data change value section. So just be cognizant of the fact that depending on the order, right? If it is historical data, if it's coming in and we're doing any form of expression and evaluation, right? Looking at has the value changed. If we're changing the order of these like batched or buffered message processing, then obviously we're not going to be able to determine the change increment or thresholds accurately at ThingWorx because of the fact that we're optimizing for multi-threaded processing. And this is one of the reasons why good cloud scale application design, we should be doing those types of things down at the edge, close to the machine as possible.